The process begins with a large steel billet being placed inside a high-temperature industrial furnace. It is heated gradually until the entire billet reaches a red-hot to orange-hot state. At this stage, the temperature usually reaches 1100 to 1250 degrees Celsius, which softens the steel enough for heavy forming without cracking. Once the correct temperature is reached, the glowing billet is removed from the furnace using heavy handling equipment and transferred quickly to the forging station before heat is lost. The first operation begins with a center punch. A powerful punch presses into the middle of the heated billet, creating an initial opening. As pressure increases, the center hole expands further, transforming the solid billet into a hollow structure. This step is extremely important because it determines the basic internal shape of the final forged part. After the hole is formed, the workpiece is positioned under a massive forging press. The forging press compresses the billet vertically with enormous force. During this compression, the internal grain of the steel becomes denser and more uniform. This greatly improves mechanical strength, durability, and resistance to fatigue. Because forged metal has a tighter grain structure than cast material, it performs much better under heavy load. After vertical compression, the hot workpiece is rotated sideways. It is pressed repeatedly from multiple directions. Each press gradually controls the wall thickness, outer diameter, and overall symmetry of the hollow cylinder. The operator carefully adjusts positioning during each strike to maintain balance in the shape. As the forging continues, excess material is redistributed evenly throughout the body of the part. The repeated pressing also removes internal stress concentrations. At this stage, the cylinder begins to develop into a more precise forged ring form. The outer surface becomes smoother while the dimensions become more consistent. If needed, reheating may be performed between forging stages to maintain ideal metal plasticity. When the desired dimensions are reached, the forged piece becomes a uniform ring-shaped blank. This forged ring now has a strong internal structure and excellent load-bearing characteristics. After forging, the part is moved for cooling under controlled conditions. Controlled cooling is important because sudden temperature changes can create unwanted stress or deformation. Once cooled, the forged ring often goes through heat treatment. Heat treatment further improves hardness, toughness, and structural stability. After heat treatment, the part enters the machining stage. Precision lathes remove excess material and refine both inner and outer diameters.